Good day everyone and welcome back to our channel. This is Liceo Math Club's current Executive Secretary, Gabriel Hannah Abelia, and today we will be talking about rational equations, particularly how to solve for x. Now what are rational equations? These are equations containing at least one fraction whose numerator and or denominator are polynomials, like p of x over q of x. In simple terms, a rational equation is an equation that has one or more rational expressions. So these are examples of rational equations because they contain at least one polynomial. In solving for x, there are two common ways that people use: cross-multiplying and multiplying both sides by the least common denominator. We cross-multiply if we have one fraction equal to one fraction, that is, if the fractions are proportional. Now let's take this as an example. 2 minus x over 3 plus x is equal to 1/2. Now let's solve for the value of x. Cross-multiplying is applicable because the problem only has one term on each side of the equation. Now let's cross-multiply. 3 plus x times 1 is 3 plus x, so is equal to 2 times 2 minus x. Now, we simplify, so 3 plus x is equal to 4 minus 2x. Next, transpose the variables to the left side and the constants to the other side of the equation. Now, we will get 3x is equal to 1. This will lead us to the answer x is equal to 1/3. The second option is applicable for any problem but is commonly used when there is more than one term on any of the sides of the equation. Note that when solving for rational equations, all fractions should disappear after the first step. Now let's solve for this one. 5 over x minus 1/3 is equal to 1 over x. As we can all see, there are two terms on the left side of the equation, so we cannot apply cross-multiplying directly. So the first step in answering this problem is identifying the least common denominator. In this case, the LCD is 3x, so we multiply that to both sides for us to eliminate the fraction. Now, let us distribute 3x inside the groupings. So 3x times 5 over x, cancel x, we get 15. Minus 3x times 1/3, cancel 3, and we are left with x. On the other side, 1 over x times 3x, cancel x, which leaves us to 3. Now we get 15 minus x is equal to 3. Now let's separate the variables and the constants. So we are left with negative x is equal to negative 12. Let us eliminate the negative sign by multiplying both sides to negative 1. This leads us to our answer, which is x is equal to 12. Now let's try solving the following examples. First example, 5 over x minus 2 is equal to 3 over x. So we should first find out what method is appropriate. Since there is only one term on both sides of the equation, cross-multiplying would be easier. An additional step that would make it easier to check if the answer is correct is to determine the restrictions for the problem. We need to take note of values for x that would make the whole equation undefined. In this case, the only numbers that would make the problem undefined is 2 or 0. Therefore, x is not equal to 2 and x is not equal to 0. Now let's cross-multiply. 5 times x is 5x, which is equal to 3 times x minus 2. Let's simplify, so it will be 5x is equal to 3x minus 6. Then bring the variables to the other side, so 2x is equal to negative 6, which brings us to the answer x is equal to negative 3. The answer does not go against the restrictions, so our answer is accepted. Now our second example, x plus 3 over x minus 2 is equal to x plus 4 over x minus 5. Now our restrictions would be 2 and 5, therefore x is not equal to both 2 and 5. The best way to approach this problem is to cross multiply. So x plus 3 times x minus 5 is equal to x minus 2 times x plus 4. Let us simplify, so using the FOIL method, x plus 3 times x minus 5 would be x squared minus 5x plus 3x minus 15. X minus 2 times x plus 4 would be x squared plus 4x minus 2x minus 8. Combine like terms, so we will now have x squared minus 2x minus 15 is equal to x squared plus 2x minus 8. X squared from both sides can be cancelled, and then let's transpose all the variables to the left side and constants to the right side. We now have negative 2x minus 2x is equal to negative 8 plus 15. Simplifying further, we will get negative 4x is equal to 7. This leads us to our answer, x is equal to negative 7 over 4. Since our answer is not 2 or 5, the answer is accepted. Our next example, x over x plus 2 plus 2 over x squared plus 5x plus 6 is equal to 5 over x plus 3. So for this problem, there are two terms on the left side, so multiplying both sides with the LCD is the easiest approach. But before everything, there is a quadratic expression present, so we need to factor this out. X squared plus 5x plus 6 will now be x plus 2 times x plus 3. Now our restrictions would be x is not equal to negative 2 or x is not equal to negative 3. Next, let us determine our LCD. By looking at the denominators, we can easily tell that our LCD is x plus 2 times x plus 3. So let us multiply it to both sides of the equation. So distribute the LCD inside the groupings. X plus 2 times x plus 3 times x over x plus 2. Cancel out x plus 2, we are left with x times x plus 3. Plus x plus 2 times x plus 3 times 2 over x plus 2 times x plus 3. Cancel everything in the denominator, we have 2. Now to the other side, x plus 2 times x plus 3 times 5 over x plus 3. Cancel x plus 3, we are left with 5 times x plus 2. After eliminating the denominators, we now have the equation x times x plus 3 plus 2 is equal to 5 times x plus 2. Simplify this and we will get x squared plus 3x plus 2 is equal to 5x plus 10. Now since we have a quadratic expression again, we should put this in standard form, which is equating everything to 0 and simplify. We now have x squared minus 2x minus 8 is equal to 0. To find the values for x, factor this expression and we will get x plus 2 times x minus 4 is equal to 0. Equate each factor to 0 and we will have values for x which are negative 2 and 4. Since one of our restrictions is negative 2, the correct answer for this problem is 4. Now let's find out and check the difference. Now let's see why and how negative 2 will make our example undefined. Substitute negative 2 to our problem, we will have this. Now simplify. When we simplify, two terms have denominators that are 0, which automatically makes negative 2 not a solution for this problem. Now let's substitute 4 to our equation. We get this, and let's simplify. We have 2/3 plus 1 over 21 is equal to 5 over 7. Add the two dissimilar fractions and we now have 15 over 21 is equal to 5 over 7. Change it to lowest terms, wherein 15 over 21 is also 5 over 7. And now since we have the same values on both sides, this makes our solution correct. Our next example is quite similar to the last one. 5 over x plus 3 plus 2 over x squared minus 9 is equal to 4 over x minus 3. Because of the presence of x squared minus 9, which is a difference of 2 squares, we need to factor this out for it to be easier. Now we have x plus 3 times x minus 3 on the denominator instead. Now let us identify the restrictions. Only 3 and negative 3 will make this problem undefined, so our answer can't be one of these. Next, the LCD is already evident by looking at the problem, which is x plus 3 times x minus 3. Multiply it to both sides now. X plus 3 times x minus 3 times 5 over x plus 3, cancel x plus 3, 5 times x minus 3 is left, plus x plus 3 times x minus 3 times 2 over x plus 3 times x minus 3, cancel the whole denominator because it is similar with the LCD. Now we are left with 2. On the other side, x plus 3 times x minus 3 times 4 over x minus 3, cancel out x minus 3, and 4 times x plus 3 is left. Now we have the equation 5 times x minus 3 plus 2 is equal to 4 times x plus 3. Let us simplify this and then separate the variables and constants. Now we have 5x minus 4x, which is x. That is equal to 12 plus 13, which is 25. So the value of x is now 25. Since our answer is not 3 or negative 3, the answer is accepted. Now our last example, 3 over x minus 1 minus 2 over x minus 4 is equal to negative 6 over x squared minus 5x plus 4. As always, we should factor out everything in the denominator first. X squared minus 5x plus 4 is now x minus 1 times x minus 4. The only numbers that would make this undefined or make the denominators have a value of 0 are 1 or 4, so x should not be any of these. Now let's move on by determining the LCD. As we can see, the LCD is x minus 1 times x minus 4. As what we did in our last examples, multiply it to both sides and simplify. So x minus 1 times x minus 4 times 3 over x minus 1, cancel x minus 1, we have 3 times x minus 4, minus x minus 1 times x minus 4 times 2 over x minus 4, cancel x minus 4, and we have 2 times x minus 1. On the other side, x minus 1 times x minus 4 times negative 6 over x minus 1 times x minus 4, cancel the denominator in the LCD, we are left with negative 6. Now our equation is simplified to 3 times x minus 4 minus 2 times x minus 1 is equal to negative 6. Let's simplify further and transpose the variables and constants. And now we have x is equal to negative 6 plus 10. Negative 6 plus 10 is 4, which means x is equal to 4. But then, going back to our restrictions, x should not be equal to 1 or 4, and we only have one value for x, so there are no choices like the past example. Therefore, this problem has no solution. That's all for today, guys. Thank you so much for watching. Again, this was Gabriel Hannah Bellier, Liceo Math Club's Executive Secretary. Hope you are staying safe and healthy, and please don't forget to like and subscribe.